Welcome to Brain Vision.
Problem 28.2, we have the Bohr model of a hydrogen atom, which the electron moves in a circular orbit of radius 5.3 times 10 to the negative 11 meters. That's this vector here, r, with a speed of 2.2 times 10 to the 6 meters per second. That's this vector b. And we're reviewing the atom in such a way that electrons orbit in the plane of the paper with the electron moving clockwise. We find the magnitude and direction of the electric and magnetic fields at the point produced by the particle. Okay, so let's start with the magnetic field. So we start with the equation for the magnetic field of a moving point charge. So that's going to be B is equal to mu naught over 4 pi. And then we have Q V sine of phi over r squared. Okay, so what we need to do is we need to first write in what the charge of the electron is. So that's just going to write down as a QE. So mu naught over 4 pi. And then we write down what V is. That's just a number that we're given. And then sine of phi is something we need to figure out. So sine of phi, that phi represents the angle between the vector V and R. And so since that is 90 degrees, we have sine of pi over 2, which comes out to be 1. Okay, and we also have V in here, so that's just a number again. And then r squared, that's just going to be this number squared. So we're just left with numbers. And so what that comes out to be is 12.55 Tesla. And we need to determine whether which direction it is. Is it into the page or out of the page? Okay, so we need to follow our right-hand rule here. So we take an axis. I'll start with into the page. We have the electron that's going around in a circle around our thumb. And then that's going to point into the page using my right-hand rule. However, because the electron charge is negative, that's going to be out of the page. So k hat. Okay, so that is really unrealistic. And that's what the point of this B field calculation is supposed to be, that 12.55 Tesla is really unrealistic for a model this size. But let's go to the electric field case. So the electric field is just going to be Coulomb's law. So that's just going to be 1 over 4 pi epsilon naught Q over r squared. So there's nothing special about this r and q here. That's just a charge and a radius. So those are numbers. So we can plug in what those are. And we'll get 5.126 newtons per coulomb. And so what direction is this going to be at the nucleus? So this is going to be a force that's going to be directed towards the electron as it travels around. So we can write r hat.